Hey everyone, welcome to the first video of a cylinder graphing tutorial. This first few videos are going to be theory heavy, but we will still be able to get some graphing done. So the idea with the cylinder is we're going to need two circles in 3D space, and we're going to need lines that will connect the two circles together. Now we've already seen how to make a circle in 2D space, and we're gonna be doing these things using discrete points because as far as I know, you can't write a 3D equation that would graph any shapes. So first what we're going to do is we're going to need a number of points. I am on a JavaScript IDE, so we're going to start with. We're going to need a number of points, so let's just call this n, and I'm going to set it equal to 8, and let's also make an array that will save all the points on the circle. And for now, let's do 2D. So the equation I'm going to be using is x squared. This is going to be centered at 0, 0. X squared plus y squared is equal to r squared. And what this means is we're going to need a radius. So let's also make a radius. And the way you use this is you're going to need let's iterate from 0 degrees to less than 360 degrees. So basically, if we make it all the way around, we don't want it to hit back at 360 because this is going to look the same as 0 degrees. And then let's do this is best done parametrically. So basically, it's going to be points dot push, and this should really be 360 over n. This should really be 4 r times cosine of the angle. So cosine likes radians, and it's easier to work with degrees. So which means we're going to need a function that converts from radians to degrees. Let's make one. Let's do const degrees equal to radians, and it's going to return 180 times radians divided by pi. So now we can just do degrees. Wait, no, what am I doing? We want to convert degrees to radians. So this should really be math.pi times 180, no, times degrees 180. Is that right? If we make a mistake, We'll find out shortly. Radians of I is similar times math dot sine. All right. So this will give us all the points on the circle if it was in 2D space. But since we want 3D, we're going to introduce a z value that for now is going to be placed at 0. So this is going to look exactly like a 2D circle. But what we can do now is we can pick which axis we want it to be constant at. So for example, if I want to see a circle on the xz plane, I'll just simply make this value now the z value. So what does that look like? Doesn't look like we made mistakes. So let's try it out. If you want to, we can start rotating this. See what this looks like. So let's rotate this on the x-axis. Seems like we might have made a nope. That's right. So -4, 0, 0 is our next point. Okay, so you can see that as we're rotating on the x-axis, you can see this circle forming, and if I put this back to 0, it just looks like it looks really thin. I want to leave this x rotation at 9 degrees, so you can see the circle forming. This is 0, 0, negative. Positive, negative. All right. So basically, you get the idea on how you can adjust where you want your circle to lie. The next thing is we're gonna need two of them for obvious reasons. So let's make a function that basically what we're going to do is we're going to see what we're going to need. Let's start up here. We're going to need the origin. We're going to want, no, not the origin. We're going to want the center of the circle. We're going to want the radius. And for rotation, we're just going to keep it at 0. So we're going to need the points. And at some point, we're going to have to return the points. And let's also give it an n for how many points we wanted. So this one, so for this time we used 8 points. If you want a higher definition circle, you can use more points. But what that will mean is you're going to have a bigger table. You want to see what your circle looks like, you just click on your settings, and then you can change this. You can just enable lines. And you're going to have to close it by setting your initial point as the endpoint as well. So this is, so even though we end up with an octagon, we look at it as an approximated circle. So if you want 100 points, you can. You're going to have 101 rows, presumably, but you'll end up with a much smoother looking circle than what I have here. Right. So the way we're going to define this, the way we're going to populate this point is we'll still be using this loop here. But what's going to change is what axis we want the circle to be. Is what plane do we want to draw the circle on? So in this case, it drew the circle on the XZ plane, which is why if I have it down, let's see, if I set it back to 0, the circle just looks like it's laying down on a surface. So we want this on. So what I'm going to make it is I'm going to make it on the YZ axis. So what that means is I want to make this value 0, and I'm going to move this here. What we can do now is we print the circle at, all right, so for now we assume we're not using these values, we're really only using these two values here. But in the next video, we're going to use, we're actually going to use these values so we can get more of a cylinder going on. So for radius, let's use 4. And for n, let's keep it at 8. And you'll see that that the x and y values here will get switched. This more. So we still need this. And this function, we'll be looking for it. So let's put it up on top. There we go. The values got switched. And we can start doing the exact same thing here. These values got switched. Or rotate it on the y-axis. Let's see what it looks like. So you'll hopefully see still see another circle. No, that doesn't help. All right. So the circle is really now on the plane on the YZ plane. That's how you would do it. So in the next video, I want to show you how do we get this circle on any x, y, and z we give it. All right, so I'll see you next one.